This is going to be a demo of the first prototype of the ETG coil/ignition tester. And the setup I have right now is I have a Ford TFI performance coil, my lab mule. I have my current probe, which is this guy right here, hooked up to the scope so we can see the coil primary current, just for test purposes. I have a fixture here that I threw together to test the Cummins coils, and I'm just using right now this calibrated gap right here. It's calibrated at 20 kilovolts, and we'll just use that as a coil load. The tester itself is the very first prototype. It's got a lot of little mistakes as far as some of the holes and the cut deal is drilled. So when I send yours, the one I'm going to build for you, it'll be prettier, but this will show the basic operation and how the controls work. Looking on the back, you can see that there's a terminal strip with there's several ground connections. There's the CD coil connections. There's the coil minus for the standard coils, smart coil drive, and then 12 volts when you're running a standard coil or a smart coil. The power supply is built into the box, so you don't need an external battery or power supply or anything else. If you look on the back here, you'll see that there's a standard IEC type 3-pin power connector, and there's a power switch right here, and a USB port for further, if we have any firmware updates or enhancements to the firmware. So I'll reach around back and I will turn this on. When it boots up, it'll show the firmware version, and then it goes into the mode. Now the display shows, as you can see, RPM. It's in the CD mode, which means that this 1 millisecond, that's the pulse width driving the CD portion, and that's fixed. And then it shows you the cylinder number. So the RPM output will be commensurate with this cylinder number. Now this knob down here labeled RPM is used in most of the modes to select the value of what you want to do. The mode that you're changing is indicated by this blinking cursor. If you push this button, which is labeled mode, let me back up here, you'll see it right now it's in RPM mode. If I push it again, it goes to the pulse width mode. Now in the CD mode, turning this doesn't make any difference. Doesn't change it. If you go to over here to where it says DC, which is duty cycle, then this will change the duty cycle of the signal that's being sent to the coil. And that's good for, like I say, if you want to use this as a general purpose ignition driver for a CD ignition or something, set the duty cycle to 25%, and then you can use that to drive an external CD just like you were driving a Unilite. The third position up here is PW, is pulse width, and that will allow you to modify the pulse width to various values for driving smart or dumb coils. Typically this is used for coil on plug and coil near plug applications. The final one, if you push it again, puts it in the cylinder mode, and you can go down to a single cylinder equivalent or up to a 12-cylinder equivalent. I'll just leave it on 8-cylinder for right now. Now going back to the RPM mode, you'll notice the cursor right now is blinking in the hundreds of RPM position. If I push this knob, the cursor blinking will change to the thousands positions, and then you can go up in RPM by thousands. If you push it again, it just cycles through. Now it'll change in values of 1 RPM, 10 RPM, and hundreds of RPM. I'm just going to drop this down to let's go to 100 RPM for the purposes of further testing. Okay, so right now the coil is hooked up in the CD mode and nothing is happening. You don't hear any sound. The reason why is because this switch right here is in the kill position. Either all the way up or all the way down is the kill position. In the center position is where it runs. But before we do that, what we're going to do is I'm going to put the mode back to DC, and this is just to set up the output voltage on the CD. Now then, if I put this in the run position, the activity light blinks, but nothing else happens. what we're going to do now is take our DC voltmeter, set it for DC volts, and then I am going to put this on the CD coil minus connection. Now you notice it says 463 volts. That's really higher than I want, so I need another hand here. Let me turn this down. I've marked, oh man, I'm not getting any awards for videography. I have marked the 350 volt point with a little pencil mark right there. That should be pretty close. Let's see. 350.9 volts, but that's how you set the output voltage for right now. It's a little bit awkward, but again, typically once you have it set up, you're not going to be changing it, so it's not, I don't see that as a huge issue, but if it is, let me know and we'll see if we can come up with a plan B. At any rate, so right now the activity light blinks every time a pulse is sent to either the coil driver or to the CD portion. Now what I'll do is I'm going to put this back in the kill position. I'm going to change this to CD. Now you notice that this changed here to 1 millisecond, and now when I put it in the run position, you should hear some sound. And with 350 volts on that coil, you can see that it's firing across the gap. I'll bring the RPM up. And then you can also see, let me bring this back down here a minute. You can also see the current in the coil. Let me drop the trigger down here just a bit. See if we can get that to, so you can see this is the current in the coil. It's actually not that much current. I'm going to bring this up a little bit. Oops. Okay, now here is where you can see the peak current. You'll notice that the peak current is right here. Oops. And then what I'm going to have to do is change the sensitivity of the... Okay, so right now it's at 5 amps per division, so you can see we have a 5, 10, about 13 or so amps in the primary of the coil running off the CD. Now notice as I'm bringing the voltage up, notice how the current goes up commensurately. Now this is the peak current right here. It's a peak voltage rather. It's about 500 something volts. Yeah, about 505 volts. So you can see that the difference between that and 350 volts is significant. That's why voltage is so important on CDs. Okay, I'm going to pause this for just a second, and I'm going to switch it to the dumb coil mode, where we're driving the coil as if it were just a standard coil on plug. Okay, so what I've done is I have connected the coil minus here, and I've connected the coil plus here. Now what I'm going to do is, still in the kill position, I'm going to put it on pulse width, press the mode over to the pulse width position, and now whenever we put this in the run position, now you can hear the pulse in the coil, but nothing is happening out here because that pulse width is too short to get any appreciable current. So what I'm going to do is I'm going to take the coil current waveform, I'm going to move it down to here because it's going to be in the opposite direction than what we see here. Bring the trigger up to about here. And set this on 2 amps per division. And now we can see we just have a little bit of current in the coil. Now as I bring the pulse width up, notice how the current gets higher, and then you start hearing, let's put this on, this will be 2 milliseconds per division. So right now we're at, here's 2 milliseconds. It fires across the gap every once in a while. I'm going to bring it up till we have 4 milliseconds. Okay, so we're at 4 milliseconds. And now we have a nice fat spark jumping across the coil, and we have almost 8 amps in the coil primary. So we're getting plenty of energy, and we can fire a nice big gap. And you'll notice the activity light is flashing. The CD volts will have no effect on this because this is strictly run by pulse width. If you want to change the duty cycle, I'll show you what that does. So let me put this back into kill position. I'm going to change this to duty cycle, and I'm going to have it at 25%. Now, at 100 RPM, 25% is a fairly decent amount of dwell. So what I'm going to do is I'm going to bring the RPM up. I'm going to bring it up to 1,000 RPMs. It makes it easier to kind of see what's going on. So we're at 1,000 RPM, 25% duty cycle. I put this in the run position. Now you'll notice that that's almost the same pulse width. That's almost 4 milliseconds pulse width. Now as I bring the RPM down, because it's going by duty cycle rather than full pulse width, you'll see that the pulse width changes as RPM goes up. And now we hit a point where at 25% duty cycle, it's just not going to be able to fire the coil. Now if I go and change that, okay, there's 53% duty cycle, and you notice we're hitting 8 amps. There's 2, 4, 6. We're hitting 8 amps on the display. As I continue to increase the RPM, we're going out again. So I'm gonna run the duty cycle up just to see where we start getting a good spark. About 65%. So there's 75%. We're at 4,100 RPM. That would be like a Unilite distributor driving that coil with no ballast resistor. And that kind of gives you an idea of what the system can do. So I'm going to put this back to pulse width. And kill the switch. And that's basically how the system works. Like I said, I'll make one for you guys that'll be a little bit prettier. I'm also hoping, I ordered some labeling tape that's clear background, so it'll be black on clear, so it'll look a little bit nicer than this. But I wanted you to see that progress is being made. The unit works. It's nice and lightweight. Power supply is built in. You don't need to have a battery or any external supply. The only other thing that I wanted to tell you is that if you turn off the power switch right here, the power supply continues to hold the charge for a little bit of time. So I've just turned the switch off, and it takes a few seconds before it finally shuts down. The last thing is, always have this switch in either of the kill positions if you're changing coil connections or whatever on the back. If it's not, and the CD mode is active, if you get across those CD terminals, it will hurt you. So be careful. Anyhow, that's the tester, and like I say, I'll be working on another one. Actually, tomorrow is probably when I'll start cutting metal, and hopefully either by the end of the week or early next week, I'll have a nice, good-looking one to send you. Talk to you guys later.